Sir, you referred to the scientific missions. Can you please explain what are those major scientific missions?
In fact, we have achieved a couple of important scientific missions. You all know the Chandrayaan-1 mission, which was successfully accomplished by India. In the first attempt itself, we could successfully go to Chandrayaan orbit, and which found water molecules for the first time in the world and made all the Indians proud. The second important mission is the Chandrayaan-2 mission. In fact, we had this mission in 2019, and this is the mission really integrated all the Indians across the globe on the day of landing, and through that we are having an orbiter in the moon's orbit. The lifetime originally designed was 1 year, today the life is actually 7 years because of proper mission management what was done. And then subsequently from the orbiter we had a lander rover system which is supposed to soft land on the moon, and in fact the mission operation was so nicely done and it went as expected till the last minute. Up to 2.1 kilometer we were just on the dot, and beyond that due to some setback we could not have soft landing. Nevertheless, we could really accomplish lot of mission objectives, including placing the orbiter perfectly in the orbit, which is having a on orbit high resolution camera, feeding lot of data about the moon to the scientific community, and lot of new technologies we have demonstrated. And to once again demonstrate the successful soft landing, we are going to attempt the Chandrayaan-3 mission, which is targeted in the beginning of next year. Third important mission is the Mars orbiter mission, which is really a very great prestigious mission, because India is the first country which had the successful Mars orbiter mission in the first attempt. There are other developed countries which have successfully accomplished, but not in the first attempt. Second important point of that mission is it was a very low cost mission. You all would have heard from Honorable Prime Minister, the cost required to place that mission was less than the auto fare. That is what he used to say. So, that is the low cost mission we have accomplished. Another important thing is the AstroSat. That is another mission what we have accomplished.
Those are really wonderful, sir. Can you please tell us what are all the future scientific missions?
As I explained, we are planning the Chandrayaan-3 mission to demonstrate India's capability on soft landing. This mission is planned somewhere next year. Almost all the works are going on as expected in the expected line. All the systems are getting realized and tested. Now, next mission we are planning Aditya L1. This mission is meant for studying the corona of sun. This is another important mission what we are planning, and we are also studying the possibility of realizing a mission to Venus. These are all the things what is currently being pursued in ISRO.
But the excitement lingers around the human space exploration planned by India. Can you please elaborate on that?
We are working on the human space flight Gaganyaan program, and the program is meant for taking 2 or 3 of our brothers or sisters to the low Earth orbit using our own launch vehicle, orbit them few days and bring them back safely in the destinated site. Towards this, couple of major developments are taking place. The GSLV Mark III vehicle is identified as the vehicle, but the same vehicle cannot be used. This vehicle is getting human rated and getting requalified for the human spaceflight program. Another important development is the crew escape system. As you know, during any phase of the flight, if anything goes wrong, we have to bring our crew safely back. Towards that, the crew escape system is getting developed. Third one is the orbital module, in which lot of development is taking place. The orbital module is the one in which the crew will be sitting there. a host of technologies which includes environmental control and safety system, crew module and service module, space suits, space grade parachutes, in-flight nutrition, health and waste management. Lot of developments are taking place. In fact, before going for the actual human space flight program, we are also planning 2 unmanned vehicles demonstration. And in the first vehicle, we are planning to put a half humanoid robot that is going to fly. That development is also going on in the expected line. Now, another important development what we have made significant progress is a test vehicle. The test vehicle is required for demonstrating the crew escape system. In fact, using this vehicle, we are going to have couple of experiments. Those experiments are going to be started this year itself. Now, coming to the role of the liquid propulsion system center where I am working, we have got lot of role to play for this mission. 2 of the liquid stages, the L110 stage and a cryogenic upper stage of the Mark III vehicle, we are doing lot of tests and getting human rated. And for the orbital module, which consists of service module and crew module, there are 2 new propulsion systems getting developed. And for the environmental control and safety systems, we have to develop lot of control components and modules. That development is going on. And for the test vehicle, a liquid propellant based propulsion system is also developed. Then we need to have host of sensors for monitoring the health of the human being, the service module, crew module and the launch vehicle. That sensors are also getting developed by LPSC team.
Sir, you are a renowned expert in the propulsion area for space technology. Can you please summarize the propulsion system development for ISRO?
No, in fact, as you know, the propulsion system is a very power intensive system which is required for lifting up the launch vehicle from the launch pad and crossing the dense atmosphere and placing the satellites in the required orbit. In fact, due to simplicity, the propulsion system development, initially we started with solid propulsion system development. The first solid motor indigenously developed was having a mass of 2.5 kg, and using that it was used in a Rohini sounding rocket in the year 1967. From that time to during the last 5 decades, in the solid propulsion community has developed lot of solid motors. For SLV3, ASLV, both the vehicles were having all solid propulsion system, and PSLV, GSLV we are having solid boost solid motors, and number of solid motors are developed. And from 2.5 kg, the heaviest solid motor what we have developed is for the GSLV Mark III strap on motor, which is having 207 tons of propellant. 2 of those motors are used in the GSLV Mark III vehicle. Each motor can develop something around 600 ton peak level thrust. That is the capability in the solid motor system. Now, coming to the liquid motor, compared to solid motor, the liquid motor is complex, but it gives higher performance and better controllability is possible. In fact, the liquid propulsion activity started in the country in the year 1969. It was during that time a 5 kg thrust was developed. From that we have come a long way. For the SLV3 and ASLV, liquid propulsion based the control systems were developed and successfully employed in those vehicles. When it comes to PSLV, 2 of the stages, the PS2 and PS4 stages were liquid propulsion systems, and GSLV Mark II vehicle, if you say we are having 5 liquid stages, 4 liquid strap-ons, and the second stage is a liquid stage, and upper stage is a very high performance complex cryogenic stage. And again Mark III we are having in the core stage is a liquid stage which is having 110 tons of propellant loading and 2 Vigas engines developing 160 tons of thrust, and upper stage is again a new cryogenic engine called C25 engine. And in the liquid propulsion area, in fact, we have come a long way, starting from 5 kg thruster to we have developed a level of something around 160 ton twin engine configuration stage. In fact, lot of new developments are also taking place in the liquid propulsion area. Currently, we are working on one of the important system called LOX methane system, and very few countries are working on that system. In fact, last year we have completed the technology demonstration through a technology demonstrator. Right now our team is working on the design and development of a high thrust LPSC engine system for the future launch vehicle application. And in addition to that, we are also involved in the development of lot of technologies associated with the liquid propulsion systems. Now coming to satellites, each satellite is having the liquid propulsion. In fact, in the satellite the propulsion system is required for rising the orbit and orbit transfer and maintaining the satellite in the required position in the orbit. Towards that, the LPSC community has developed lot of thrusters starting from 1 Newton, 11 Newton, 22 Newton, number of thrusters we have developed, and a 440 Newton LAM engine which is developed for the GeoSat program, and the same engine really has brought glory to the country, because using that engine only the Chandrayaan-1 spacecraft was moved almost 4 lakh kilometer and it was placed successfully in the orbit in the first attempt itself. And same engine was used in the Chandrayaan-2 mission and Mars orbiter mission also. And we have also developed a 800 Newton deep throttling engine, which is a very unique development in the world, and that engine is essentially required for soft landing Chandrayaan-2 lander and orbiter, and this also we have successfully developed. Currently in the spacecraft system we are working on electric propulsion system, because the performance of electric propulsion system is something around 5 to 6 times higher than chemical propulsion system. If you use the electric propulsion system, the payload can be substantially increased for the same mass of the spacecraft. So, this is one area we are working. Another area where development is going on is the green propulsion system, and that is another new area. We are, in fact, we have completed couple of tests and we are in the process of development. Thereby, if I summarize the liquid propulsion development, 1969 started the development. Today the ISRO is having host of liquid engines and thrusters for its launch vehicle and satellites. I am also happy to inform the viewers that currently we are developing a high thrust 200 ton thrust engine working on liquid oxygen kerosene fuel combination, and this is a major development which is taking place. Using this engine we can enhance the payload capability of GSLV Mark III vehicle by something around 630 kg. In addition to these developments, there are advanced technologies development has taken place in ISRO, like air breathing propulsion system and hybrid propulsion system development. In fact, last week only we had successfully tested a hybrid motor. These are all the new technology developments which are taking place in ISRO.
Sir, you have led a great team to master the technology of cryogenic propulsion for our country. Can you please say the journey with which we achieved self-reliance in this technology?
As you know, among the chemical propulsion systems, the cryogenic propulsion systems gives the better performance. And in the cryogenic propulsion system, we use propellant with extreme low temperature, the liquid hydrogen at minus 253 degree centigrade and liquid oxygen at minus 183 degree centigrade. Due to extreme low temperature of this propellant combination, explosive nature of hydrogen and lower density of hydrogen, the development is very complex. In fact, the material selection, production of this propellant and its storage, handling the propellant and igniting this propellant in a very safe way without explosion, and starting the engine system, operating the engine systems, really it is very complex. In fact, we had done lot of experiments. Due to these complexities, the time required for the development is very high. Because of this, for the GSLV Mark II vehicle, we were looking for a technology transfer from other spacefaring nations, but we could not achieve any technology transfer due to geopolitical reasons. It was in the year 1995, a project was formed called Cryogenic Upper Stage Project, and we started the development on our own, and it took almost 20 years for us to complete the development and have a successful flight. It was in the year 2014, if my memory is correct, January 5th, we had the first GSLV flight successfully accomplished with Indian cryogenic stage, and India became the 6th country in the world to have this high performance and complex cryogenic technology. Subsequently, we have made the stage operational, and till today we have used 8 of the stages in the GSLV rocket. Coming to the GSLV Mark III vehicle, the upper stage is again a cryogenic stage, but the stage is a high capable stage compared to the GSLV Mark II stage, where the thrust of the engine is 7.5 ton. Here the thrust is 20 ton thrust, and the propellant loading is in GSLV Mark II is 12 tons, and here it is 28 tons. So, it was a totally a new development, and we started the development from scratch and successfully completed the development, and in the first attempt itself we accomplished the GSLV Mark III D1 mission with the first indigenously developed C-25 stage in a grand successful way and accomplished the mission. Subsequently, we have realized 2 more stages, and the last stage was used for placing the Chandrayaan-2 spacecraft in the required orbit. Now, lot of improvements we are doing. Same stage we are enhancing the capability by increasing the propellant loading from 28 ton to 32 ton, and the thrust of the engine we are increasing from 19 ton to 22 ton for enhancing the Mark III payload capability. And this stage is going to be used as the terminal stage for the human spaceflight program vehicle, and we are right now involved in the human rating of this stage. In fact, I am extremely happy to inform the viewers, today we have technology which was denied to India. We have developed our own technology, and we are having 2 indigenously developed cryogenic propulsion systems to our credit, and joined the elite group of only 5 more countries which are having this cryogenic propulsion systems.
From your answer itself, I can understand your passion and attachment towards the technology. So, as we come to the close, do you have any message to our young viewers?
Over the last 6 decades, Indian space program has got significant contribution for the development of the nation and the welfare of the common man. Today, the space activity has become part of the national development. I wish to say, sky is not the limit for those who aspire to work in the space program. If you take a launch vehicle or a satellite, it is a multidisciplinary game. All branches of science and engineering are involved in the development. Those who wants to work in the area, one should have got a willpower to face failures and learn from the failures and come out with great success. Really, those who wants to join in this area, I want to say that you will be having very high exciting career. One more important point I want to tell. Today, the government has opened the space activities for the private sector. In fact, we in ISRO are going to enable the private and startup systems to carry out end-to-end space activities. Considering large requirements and the space economy, really the coming years are going to be so challenging, so exciting, including the private players and startups are going to have contribute in a significant way. On this occasion, I wish some of the youngsters who are viewing this to join in the space activities, either in ISRO or in the private sector, and contribute for the growth of the country and made India as a developed nation when we celebrate 100 years of independence.
Thank you so much, sir, for your valuable time. I am sure that our viewers will benefit out of this session that covered sustainability through space operations, forthcoming and advanced missions of ISRO. We are fortunate to have a space personality like you who explained the high-end technologies of ISRO in a lucid manner that too palatable to the young viewers. I join with our viewers in thanking you once again. Thank you so much, sir. Thank you, viewers, for joining us today. Have a nice day.
Thank you. Jai Hind.